Question we'll look at has to do with the sum and difference formula, and we want to try to rewrite 75 either as a sum or a difference. You can do it either way. Anyone think that they know how to rewrite 75? Yeah?
30 plus 45.
Yeah, I would do it as 30 plus 45. Again, not the only way to do it, but that definitely works. So now we're doing a cosine sum. Okay, when we do a cosine, are the trig functions grouped together or are they mixed? Yeah,
Grouped together.
they're grouped together. So we group them cosine, cosine, sine, sine. And what symbol is going to go between them? Yeah.
Addition.
When we're doing sine, we keep it the same. When we do cosine, it's the opposite. Yeah. And what's going to be my first angle that I fill in?
30.
30. Second angle?
45.
45. Yep. And then we have to figure all of those out. 45, 30, 45. All right. So if you're not sure what those are, it's probably going to be helpful to write down the coordinate on the circle, and then we can figure them out. What's the coordinate for 30 degrees? Yeah.
Square root 3 over 2, 1/2.
Good. Let's square root 3 over 2, 1/2. And what about the coordinate for 45 degrees? Remember that one? Yeah.
You can square root 2 over 2, common square root 2 over 2.
Yep. And remember, cosine, you're looking for the x value. Sine, you're looking for the y. Okay. So what's the cosine of 30 degrees? Yeah.
Square root 3 over 2.
Square root 3 over 2 times. What's the cosine of 45 degrees? Well, Bridget, yeah.
Square root 2 over 2.
Square root 2 over 2. Minus. Now sine, you're looking for the y values. What's the sine of 30 degrees? Yep.
1/2.
1/2. And the cosine of 45 degrees? Yep.
Square root 2 over 2.
Square root 2 over 2. Now we're just going to multiply that all out, and it already has a common denominator. That usually happens when you do these. Okay, so the common denominator is 4. And what's going to go in the top on the left? Yeah.
Square root 6.
Square root 6. And on the right?
Square root 2.
Square root 2. And that's how you find the cosine of 75 degrees. Any question on that one? Okay. All right, so next question, similar to the last one, except now we're going to do a sine identity. And it's either going to end up being a sum or a difference. What would make the angle easier to work with? Degrees, yeah. So if we change that to degrees, it's going to be easier to figure out what adds or subtract. In radians, it's hard to figure out. All right. So how do we change that to degrees? Yeah.
You do 19 over pi. I mean 19 pi divided by 12 is equal to 180 over pi.
Equals 180 over pi. So yeah, the pi's will cancel. So yeah, it's just going to be 19 times 180 and then divide by 12. So that's 285 degrees. Okay. So now we just have to figure out how we can write 285 as either a sum or a difference. So if you get stuck, what you can do is list the angles like off to the side that you can use. 30, 45, 60, 120, 150, 135, Okay, any of the angles that we use on the unit circle, you just got to come up with 285 somehow. Does anybody see how we can get? Yeah, I can keep listing them. So that's quadrant 2. The ones in quadrant 3, 300, 330. Actually, these are quadrant 4. And 315.
Can you do 150 plus 135?
Yep. I also just noticed you could do 315 minus 30. You could do it that way. So just make a list of all your 30s, 60s, and 45s and just try to make that number out of them somehow. There'll always be a way to do it because I'm going to give you one you can do. So let's do it the way you said. What did you say?
150 plus 135.
150 plus 135. Yep. Okay. Now, first thing we should do is just put down the formula. When we do the sine formula, are the trig functions mixed or are they grouped? Yeah, they're mixed. So we have sine, cosine, cosine, sine. And what's the symbol that we put between when we're doing a sum for sine?
Addition.
Yep, we keep it the same. Okay, and the first angle we're going to fill in is 150. And the second angle?
135.
135. Now, probably going to be easier to write down the coordinates for those. So now we can just figure out what we need. 150, 135. Okay, so 150. 150 would be, let's see, that's 180. So 150 would be right there. Okay, what would be the coordinate for 150? Well, first, is it the 45-45 or is it the 30-60 triangle?
30-60.
It's the 30-60, so it has the long side and the short side. And they're negative, positive. Yeah.
Negative square root 2.
Yep.
And positive 1.
Positive 1/2. So there's your coordinate for 150. And the coordinate for 135.
Square root 2.
It's going to be, what is it?
Square root 2 over 2. And square root 2 over 2.
Well, if they're both positive, though, you'd end up in quadrant 1.
Oh, negative.
Negative.
2 over 2.
And square root 2 over 2. So we're going to get very similar answers to the last one. It's just we may have a negative in there somewhere instead of both positives. Okay, so let's go through each one. So what is the sine of 150?
1/2.
1/2. It's the y value. What's the cosine of 135?
Negative square root 2 over 2.
Yep, x value. Plus, how about cosine of 150?
1/2.
What is it?
1/2.
Cosine of 150 is the x value.
So negative square root of 3 over 2.
Yep, negative root 3 over 2. And what's the sine of 135?
Square root 2 over 2.
Square root 2 over 2. Okay. So when we put that all together and write our final answer, what do we get? Did they know what that first square root would be?
Negative square root 2.
Yeah, 1 times negative square root 2. And then how about the second one? Yeah.
Oh, negative square root 6.
Yeah. Now, there's different ways you can write that. You could just say square root 2 minus square root 6 over 4. That's the same. But that's how you do it. Okay, so any questions on that one? A little bit harder because you got to work with the radians, but I think if you change the degrees, then it's not as bad. I would not recommend trying to do it in radians. Okay. Good. So this one is similar to the first two, but now I want to take something that's been broken up using an identity, and I want to combine it back into what it would have been. Okay, just a single trig function and the angle. So first of all, is this a identity that would have something to do with a sine sum or difference, or is this a cosine sum or difference?
Sine.
Yeah, it has to be sine because they're mixed. Sine, cosine, cosine, sine. So it would have to be a sine. And now, when it's a sine and you have a minus here, what would have been in parentheses here?
Addition. Subtraction.
One of those two.
Subtraction.
Yeah, when it's a sine, you keep it the same. Okay, when it's a cosine, you switch it. What would have been your first angle?
20.
20. And your second angle?
15.
15. So this originally would have been the sine of 5 degrees. We're not figuring out what that is. We're just combining it back together. So any question how we recombine that? Okay. Okay, so in this one they want us to prove that the cosine of pi over 2 minus alpha equals sine alpha. The only kind of proof you're going to have is either a sine or a cosine, and a sum or a difference. And then we just have to fill it in. So, can anybody tell me what this left-hand side would be rewritten as if you use the cosine difference identity? Yes.
Cosine of pi over 2. And then cosine of alpha.
Okay.
Plus the sine of pi over 2 times the sine of
2 sine alpha. Okay. So Sophia gave us that, so now we're going to have to figure out what that is. Might help to have the coordinate for pi over 2. What is the coordinate?
0, 1.
0, 1. Yes. So the coordinate is 0, 1. So what's the cosine of pi over 2? Yeah.
0.
So that's going to be 0. And what's the sine of pi over 2? Yep. 1. And 0 times cosine, that's going to cancel out. And then when you do 1 times sine, what do you get? This sine. And that's exactly what we wanted to show. So when you're doing these problems, there's really only 2 steps in the proof. I'm going to ask you to show me one of the 2 steps. Any question on that one? Okay, so now looking at the 7-6 material. The first one we're going to do, again, probably the most difficult one, is where you've got something that's squared and you have to eliminate that so you can factor it. So what do we always want to make sure that it's equal to first? Yeah?
0.
Yeah, we want to get it equal to 0. So do we want to put everything on the right, or do we want to put everything on the left? The left?
Right, with the neck, but because you don't want the square root to be negative.
Well, I don't want the squared term to be negative. Correct. But if I put it on the right side, it's only going to temporarily be negative.
Okay.
So if you put it on the left, you're going to have an extra step, which is multiplying everything by -1. I would put the squared term on the right.
Is that always the case?
Do you always put it on the right?
Or like, do you always remove the squared one?
Well, you want to start out with the squared one negative, because when you substitute the Pythagorean theorem for it, the negative is going to cancel.
Okay.
So
So you want to make that negative.
to start, yeah.
Yeah.
So move that to the other side. Now it's very similar to a quadratic. You've got 3 terms. The last one is a constant. The exponent is 2, and that's a 1. But you have 2 different trig functions. Okay. Which one do we always substitute for?
The squared one?
The squared one. Okay, you always substitute for the square. What you have to substitute is an identity. It's always a Pythagorean identity. So now we need the Pythagorean identity that has sine squared. Don't even remember what that is. Definitely something I would put on your reference sheet if you're going to make one. Yeah.
Oh, wait. Cosine.
Yep.
Is it 1 minus cosine squared?
Yeah. Yeah. So it's sine squared plus cosine squared equals 1. And then you brought the cosine squared to the other side. So 1 minus cosine squared is sine squared. Yep. So you're going to substitute in for sine squared 1 minus cosine squared. And when you substitute, you need to put it in parentheses because it's always going to be a distributive property. I guess unless there was not a number here, then there would be no distributive property. But there is a number. So now this is the reason why I said to put the squared term on the right, because when you multiply, what's negative 2 times negative cosine squared?
2 cosine squared.
Now it's positive.
So if there wasn't a number in front of it, you wouldn't want to make it negative? If there wasn't, yeah.
So if there wasn't a number in front of it, then yeah, there wouldn't be anything you'd be distributing to it to cancel the negative. So then you probably want to put it on the other side. It's not a big deal what side you put it on. It's just a matter if you have to multiply by negative 1 to fix it. All right, so negative 2 cosine squared. What's negative 2 times 1? Negative 2 plus 1. Negative 1. So that's my constant. So I did that. And now I'm just going to bring down cosine. Okay. If it's confusing to look at that when you try to factor it, then think of it without the cosines. Try to factor that. Okay, if you can factor that, you can factor the top. Okay, when we try to factor it, what would be our first term in each parenthesis? And let's try to do it with the cosines if we can. Yeah.
Cosine x and then cosine. Oh wait, no, cosine x. Wait, no. 2 cosine x.
2 cosine x and
Cosine x.
cosine x. Now, what about my symbols?
We have plus and minus.
Right, you're going to need one of each. I'm just going to try them in the order you said. And 2 numbers that multiply to give us 1. Well, I don't usually make the factoring very hard here. It's not like you have the number 24 at the end. You've got to try like 12 times 2, 6 times 4. You know, it's usually an easy factoring problem. Relatively. All right, so let's see, does that work? 2 cosine squared minus 2 cosine plus 1 is minus 2 plus 1 is what we want right there. No. So what do we have to switch?
What's the sign?
Just switch the signs. The symbols. All right, now we have 2 cosine x minus 1 cosine x. Perfect. That's what we want. Okay. Now, you might have some problems on the test that are already starting you at this point. If I start you at this point, the factoring's already done. You just have to take each factor and do what? Yeah.
Set equals.
Yeah, set them equal to 0. And cosine x plus 1 equals 0. Okay, so on the left, what's cosine x going to equal?
1/2.
Yep, that's going to equal 1/2. And now you've got cosine equal to a positive number. Okay, so we got to kind of remember that. Cosine's equal to a positive. So where are we looking for answers?
1 and 4.
1 and 4. Yep. how are you going to get the answer in quadrant 1?
Take the inverse cosine.
Yep, take the inverse cosine on each side. Now, I would always do it in degrees first, because if you need an exact answer, you'll get a nice answer in degrees. You can change it to radians by hand. So let's make sure we're in degrees. Right, we get 60 degrees, or pi over 3 radians.
Is there radians on a scientific calculator?
Oh, you mean to switch the mode? You can press the DRG button and switch the mode, but switching the mode is not going to help you do this problem.
Yeah, I wanted to make sure I wasn't in. It
Yeah.
doesn't like say at the top.
So yeah, if you press the DRG, you see the DRG button
Yes.
at the top? That's how you switch between degrees and radians.
Okay.
All right, so we get 60 degrees. What's my formula for quadrant 4?
360 minus.
Yep, it's going to be 360 minus. And then what's 360 minus 60?
300.
300. Okay, so there's the two answers from here. Now, when you solve this one, all you have to do is figure out where cosine hits its lowest point. Right? You could do the inverse cosine of x, or just think of the graph. Where does cosine hit its lowest value? Yeah.
Pi, so
Pi.
180.
Yeah, so 180. Yep. And there is no second answer because cosine doesn't hit -1 twice. It only hits it once in a cycle. Okay. And those are your 3 answers. If you want them in radians, pi over 3, 5 pi over 3, and pi. But I would always do degrees first. Okay. Any question on that one? All right, so let's look at that one. So secant x equals cosecant x. What do we usually get it equal to? Yeah?
0.
Yeah, we usually get it equal to 0. But the problem here is I don't like having these secants and cosecants, and they're not squared. So there's no Pythagorean identity that I can substitute in. So anyone have a thought what we should maybe do first? Yeah?
Maybe turn into cosine.
Okay, we could turn everything into cosines and sines. What is secant if you change it?
1 over cosine.
So that's 1 over cosine. All right, and what is cosecant?
1 over sine.
So it's 1 over sine. So it's okay to do that. Now you have a proportion. So I mean, you could cross multiply. And now you've essentially turned this problem basically though into the same kind of problem you had before. 1 times sine equals 1 times cosine. So it's still kind of the same problem. We can work with that though. That's fine. A hint I'm going to give you is I don't want to get it equal to 0 here. I want to get it equal to 1. How could I get a 1 on one side of this? Yep.
Divide it either by sine or cosine.
Yeah. What do you want to divide each side by?
Sine.
You want to divide each side by cosine?
Sure.
Yeah, that's a good idea. So let's divide each side by cosine. I just don't want to deal with cotangent. I don't want to have to flip it. Because watch what happens. If you divide each side by cosine, what do you get on the right side?
1.
You get 1. And what do you get on the left side?
Tangent.
Tangent. Now you got rid of having 2 trig functions, and now you just have 1. How would you get x by itself there?
Take the inverse.
Yep, you take the inverse tangent, and you'd be looking for an answer in quadrants 1 and 3, because that's where tangent is positive. So that's a trick you can use, not when you have something squared. When you have something squared, you definitely want to use Pythagorean identity. But you can try dividing both sides by a trig function to see if you can reduce that into one trig function instead of two. Any question on that one? Okay. All right, so this question, this is from chapter 8, so solving the triangle. So we're being given an angle, a side, and an angle. And ASA is one of the three types that you would solve with law of sines. All right, so what's the first thing we usually do with the stuff in that picture?
Put it off to the side.
Yeah, just put it off to the side to kind of make our table. So we've got A, B, and C. Alpha, beta, and what's that Greek letter that we're using now? Gamma. Okay, do we know A?
No.
Nope. So we got to find it. Do we know B?
No. Oh,
Yeah.
Well, yeah, we know it because it's opposite beta. So we do know B. Do we know C?
No.
Nope. Do we know alpha?
40 degrees.
Yep, that one's labeled as the 40. How about beta?
No.
Nope. So we already have three things we don't know, so we have to know gamma. It's 100. Okay. So what could we find first that we really don't need law of sines at all for?
Beta.
Yeah. What's beta going to come out to?
40.
Yep. Because they all have to add up to 180. Now, it's going to be a special case. Because what kind of triangle is this now?
Isosceles.
It's isosceles, which means what?
The A and the C. Or no. The A and B will equal each other.
Yeah, so really, we can answer that right now. That usually doesn't happen. But because it's isosceles, and we notice that, we got two sides that are the same. Okay. We still have to find C, though. All right? So to find C, that's where we need the law of sines. And on the left, we always want to fill in the row that we're most confident about. Well, in this case, we really have two rows, so it doesn't matter. We're filling in that row, right? The sine of 40 over 7.
Mm-hmm.
Whether you want to think of it as row 1 or row 2, it's the same row because it's isosceles. But what goes on the other side to solve for C?
The sine of 100 over C.
Sine of 100 over C. And now how do we solve it?
Cross multiply.
Cross multiply. So what will C equal as an exact answer?
7 sine 100 divided by sine 40.
7 sine 100 divided by sine 40. And that's it. So just type it in, see what we get. 7 sine 100 divided by sine 40. Make sure you close your parenthesis when you're done for your first argument before you hit enter. Before you put your divided by sign. 10.725. So 10.725. That's how you find C. So that's the type where they give you the two angles. Any question on the type where they give you the two sides and you have to use inverse trig to get one of the angles? That's like the last one we did in class. And remember, there were three different possibilities for that one. One solution, two solution, no solution. We're going to be focusing on the type that we did in class. That's what will be on the test tomorrow. All right. Any other questions?